I just want to give you a brief overview about what Q3D is all about. So who are we? The Q3D team is a team of about 25 members spread across the US, Europe, and East Asia. The list of team members is written on the slide, but I want to especially highlight the people shown in bold here, which are the team members who are right now actively involved in the software development. Some of whom will also walk you through the notebooks today. So a special thanks to all of those who are working so hard these days and trying to make the software ready for the first JWST science data. The Q3D team was awarded almost 30 hours with NIRSpec and MIRI to observe 3 distant quasars between redshift 0.4 and 3, with the goal to spatially resolve the kinematics and the gas phases of the multi-phase AGN-driven wind, potentially AGN-driven outflows, in addition to host galaxy parameters, to really understand the interplay between what the AGN, what the quasar does to the host galaxies in these particular poster-child cases. So we'll be investigating these 3 quasars using the NIRSpec and the MIRI IFU, using various gradings and settings that you'll see here on the slide. And because we are observing quasars, we have to deal with quite a significant contribution from the point source, from the PSF, and being an ERS team, we have promised to deliver to the community a PSF decomposition and analysis tool that we call Q3D Fit, and this is the topic of this webinar. Just a quick example or showcasing what we will be trying to do. So these are our 3 quasars in redshift, between redshift 0.4 and roughly 3. And on the x-axis, you see the wavelength range that JWST is going to cover. And the filters, gradings, and settings marked in blue and pink are the ones that we will be using for each object respectively. So you can see that with basically one shot, one observation with the JWST, we will be observing traces of the ionized gas phase, the molecular gas phase, star formation rate traces, and traces of shock diagnostics, basically all in one go with JWST. So it's a really powerful telescope, and we're very hopeful and very excited about these first data to come in very shortly, hopefully. Yeah, like I mentioned before, we are observing quasars. Our sources show a range of contrast ratios between the quasar itself and the underlying host galaxy. And we're mostly interested actually in what's going on in the host galaxy with the gas and the stars and the continuum emission. So we have to remove this point source. And observing with an IFU, that means that we will be dealing with a wavelength dependent PSF, but also with a spatially varying PSF, making this exercise quite a challenging one. So hopefully Q3D Fit will be able to do a careful PSF decomposition, not just for quasars, but potentially also for other science cases, and showing you what we are doing with Q3D Fit and the main philosophy behind our fitting software is the topic of this webinar.